Introduction to Probability. We are now in the second part of our course in Math 3. So as you recall it, the title of Math 3 is Statistics and Probability. And this is the beginning of the second part. What is a random experiment? Okay, I will begin with experiment. An experiment is a process that produces outcomes. Well, it's not exactly like the experiment the way we understood it in science. In science, what we do is we do things. We go to the laboratory and we do things, but we are doing it because we are interested about the outcome of what we did. And so somehow that idea is also inside the idea of experiment as it is understood in statistics. It is a process that produces outcomes. Now, what about random? What about the experiment being random? Well, we know random to be something that is unpredictable. It is something that is uncertain. And so a random experiment is a process that produces outcomes. Yes, it produces outcomes, but we are not exactly sure what particular outcome will happen at a particular instance. We could have some idea about the possible outcomes. Okay, we have some idea about the possible outcomes, but we are not quite sure about what's going to happen at a particular instance. An outcome, by the way, is the result of an experiment. It is also one of the observations in the experiment. So these are examples of random experiments. You are selling a life insurance policy to a customer. And what would be the outcome? Or what could be the outcomes? The outcomes can be either the customer agrees to buy your life insurance policy, or maybe the customer will not agree to buy. And in computer science or in IT jargon, you call this as 1 or 0. If the customer agrees to buy, we call it 1, or we assign a value of 1 to it. When the customer does not agree to buy, we assign a value of 0. Let's say, for example, someone will shoot a ball from the free throw line. So what are the outcomes? Either he makes the shot or he misses the shot. How about when you roll a pair of dice? No, not a pair of dice. Let's say, for example, just one die. Okay, so when you roll one die, the outcome can be either 1, 2, 3, 4, 5, and 6. When you roll 2 dice and you are interested on the sum, what's going to be the sum when I roll 2 dice? So the sum that will appear can be either 2, 3, 4, 5, so on and so forth until 12. Trial. So you will also meet this often in probability trial. The moment you do the experiment, that is one trial. And if you were to do the experiment many times, so the number of times you will do the experiment is what you call the number of trials. So if you did the experiment 11 times, then the experiment is said to have 11 trials. What is the sample space? So it is the set of all possible outcomes. So when you sell a life insurance policy to 3 customers, this is the sample space. This is the sample space. These are all possible outcomes that can happen. Either all of them agree to buy life insurance policy from you. Here, the first 2 customers buy, but not the third. Here, the first and the second customer buy, but the second customer did not agree, to buy a life insurance for you. And this one would be the event or the outcome when no one among the 3 customers decide to buy life insurance policy. Now, how about this? This is the random experiment, okay? You have 2 pairs of shoes, Nike and Puma, and 2 shirts with colors blue and white. And so you will choose how you will go to school, the shoes that you are going to wear and the shirt that you are going to wear. That has an outcome. The manner of choosing is going to have an outcome. It's going to have an output, so to speak. In how many ways can you go to school wearing a pair of shoes and one t-shirt? And so this is the sample space. You can go to school, okay? You can go to school with Nike shoes and blue shirt, or Nike shoes and white shirt, Puma shoes and blue shirt, Puma shoes and white shirt. So this set is the sample space. It is the set of all possible outcomes. Okay, so you can visualize the sample space by creating a tree diagram. So let's say, for example, the experiment is about flipping a coin and rolling a die. So the experiment is about flipping a coin once and rolling a die. Okay, so the first phase is either the outcome is head or the outcome is tail. In the second phase, when the outcome is head and when you roll a die, this would be all possible outcomes for the number that will appear in the die. It can be 1, 2, 3, 4, and 5, and 6. Or when what happened was the tail. Okay, if in the first phase the outcome is tail, and then when you roll the die, these are the outcomes. These are the possible outcomes. So all in all, what will be the sample space of this experiment? It can be head and 1, head and 2, head and 3, head and 4, head and 5, so on and so forth. And by listing all possible outcomes, you get to see the elements of your sample space. So all of this would be the elements in your sample space, and taken together, that is your sample space.